I'm CK. A year or two ago I built one of these digital oscilloscopes with a color LED or LCD screen, and I'll post a link to that in the description if you want to take a look at that. I think that was about $25 to $30 US. But now from Whadda, Velleman, I found their educational LCD oscilloscope. It's a big box too. That's a lot bigger than anything I've gotten from Whadda before. It's a black and white scope and looks like it has some good features and should be pretty straightforward to put together, but we'll see how well this one works and see if it might be a better option for you. And this one cost, I believe, about $50 US. Again, I'll put a link to the product in the description. So we'll put it together, see how well it works, see how fast it refreshes, which is what I'm probably the most concerned about. And I hope you enjoyed the video. Had to back the top camera off because this box is so big. Educational LCD oscilloscope. Build your own oscilloscope. High contrast LCD screen. 84 by 128 pixels, which is not a lot, but it's okay. 100 kilohertz measurement. Soldering required. Good. Signal markers, frequency, dB value, true RMS readouts. Huh. It's a level 3 kit. Looks like it's got online instructions. Meant for educational or experimental purposes only. In other words, don't use this in a production environment. Anything else on the box? Nothing else visible on the box. Premium Makers brand by Velleman. I don't know what that means, but everybody's got to have a slogan. Let's see what's in here. Piece of packing material to recycle. Okay, we've got, let's look at the circuit boards first. Move this to the side so we can focus better here. And I will zoom in a little bit now that I've got the box out of the way. Here it looks like the display board, some capacitors, resistors for probably voltage values, and here's where the LCD screen will be. Switch 1, switch 2, switch 3, 4, 5, and 6. Menu, run, stop, and these will be selecting options for stuff. All looks pretty good. The circuit board is all through hole plated with copper. A little better quality than many Velleman kits. Now we've got the other board, which has all the electronics. Looks like it's got a big old microcontroller here. Another IC that we don't know, another IC that we don't know, resistors, capacitors. There's no surface mount, which actually surprises me a little bit. Then we've got inputs, offset and gain, and a switch. And on the back, nothing particular. It's interesting that the ground plane they used is all perforated. I know why people do that, I just forget right at the moment. Then we've got cheapy probe, just alligator clips, not actual probes. Online manual URL. And there's a QR code as we saw on the front of the box. Here we've got 1, 2, 3, 4, so 6-volt battery box to power the thing. Here we have the LED screen, or LCD screen. It's not an LED. Where's my scissors? I think it probably has a display driver soldered onto it somewhere inside. There it is. Lots of little pins to solder in place. Has a part number on it that we could look up, but I probably won't. We'll set this back down so we don't scratch the surface. And I've got this Oh, I get it. That's going to be kind of on the back. Oh, to get at these two trimmers, the gain and offset trimmer. So we'll kind of mount it. Well, that doesn't make any gosh darn sense. I'm trying to orient it so it's actually accessing those two trimmer pots, and I'm confused right now. Unless they want me to put the trimmer pots facing out the back. We'll figure it out as we get there. But that's the back so you can see, not stick your big old meaty mitts on things. Here's some hook and loop fastener material, because we're not going to use the V word, because the V people get very upset about that, particularly because it's not accurate. Whole bunch of resistors, since we're doing basically a digital voltmeter. That's what a oscilloscope is, effectively a moving digital voltmeter. You could think of it that way. Lots of resistors, some 104 caps, round ones, not disc ones today, 5148 diodes, and more resistors, I guess because they're on two different boards. They probably, because Whadda tends to put these in order of how they're going to be installed on the circuit boards. So I'm going to assume this goes on the second circuit board, the control circuit board here. Just double check. Yeah, it'll be that resistor group right there. Okay, put that down. Actually, let me get another bin for that. More parts than often in this kit. I'm just going to unceremoniously dump the rest of the stuff in this bag into here. Get stuff untangled. Some transistors. Disc caps, electrolytic caps, This is a, this is the microcontroller, and you may be able to see there's a little stripe where somebody ran a highlighter along it to show that it has been programmed. This is a TI CD74 HCT 4052. I think that's a decade counter, but I'll look it up. And then another TI chip here, which I don't recognize. So we'll look those up when I take a little break in a couple of minutes. Some good tactile switches. Header to mount the two boards together. Trimmer pot. Some more caps hither and yon to set various voltage sensing rates for the scope. Nice little switch. Click, click. And that's about it. It looks like just a bunch of resistors. Oh, here's some spacers that'll separate the boards when we stack them together later. And that's the parts in the kit. Looks pretty straightforward. And the microcontroller obviously has all the brains for making it an actual DVM oscilloscope. So I get the soldering iron heated up, and we'll start putting this fella together after I bring up the build guide from the URL. And I brought the build guide up, and it gave us various statistics. One thing that is obviously very limiting is max input voltage is 30 volts peak to peak, which is kind of low. Different readouts, time and voltage. Again, this is not intended to be a replacement oscilloscope for a real shop or lab environment. It's an educational tool. Do not blindly follow the order of the components on the tape, which is always wise. And look at this. We're going to do the display PCB first, and we're going to start with resistors. And of course, we're starting with stand-up resistors. Did they make this kit just to irritate me? I'm teasing them. But let's get started and set my workbench. Is a little discombobulated tonight, but we'll work through that somehow. So we're going to start with this board with the stand-up resistors, and the first one, the 220s. Oh, just one 220. This is R1, and the way we do stand-up resistors after we complain about them is we bend one lead all the way over, then place them through the holes. Why are these not in order? Why didn't you... I would have respun the board to make these in order. R1 is here, R2, R3, R4, R5, R6. I would have respun the board to lay it out so they were in order, but that's only because that's the kind of guy I am. So we'll seat that. These leads are a little further apart than usual for stand-up resistors that you may have seen me do on, say, the Edu series of Eurorack modules, where it's very vertical. This has got a little angle. Not bad, nothing to complain about, just interesting. Then we've got 560 ohm resistor for R2. And same thing. Though, in fact, I'm going to do this. One of my concerns always with stand-up resistors is there's a potential to lean them into each other and ground the leads against each other. And since I don't like that, what I do is, if I have a row of them like this, I will change the orientation. So one is going that way, one's going that way. Obviously, resistors are non-polarized, so you can do that. But that makes it less likely that you'll make a mistake and ground them to each other or short them to each other. Just the way I do it, you can choose to do whatever you want to do. Now I'll put the rest of these on in a little bit of fast motion, so we'll have some quick resistor time here. Enjoy it. So there's the resistors for the display board. Now we're going to put a number of disc caps on. So we've got a bunch of 1 microfarad 105s. Now we're going to put the female pin header on. Where is it? And it goes on this side, of course, because the buttons and LCD panel are on this side, so we know that it's got a stack like that. So we'll set this down and support it on one side, and we'll solder one pin on the pin header, And you'll notice I'm not really paying much attention to whether it's flat or not, or anything like that. I'm just getting one pin soldered. And as you can see, it's not quite flat. It went pretty well, actually, better than I thought. So I'll press on it with my fingers behind the board, and then reheat that pin to make sure everything is completely flat, and it is all flat and good. So I can do all the rest of the pins. And put that in to support it still. And that is the pin header. And they'd like us next to go back to this side, or to go to this side, and put our buttons on. They're all the same part number button. And they click down onto the board pretty well. And they're rectangular, but not square. So it's pretty easy to know how they go on. And they've got two plastic index pins also. So we'll just shove them all in. And now we'll put the LCD screen on. Where did I put that? Go like so. Can be a little bit of a pain to get all those pins lined up and through at the same time, but just take it slow and easy. There we go. Clicks in, and while we've got it in place, what I'm going to do is I'm going to put a piece of foam on my solder pad. Put that down on there so it's held pretty tightly. And as you may notice, right here and right here are support lugs. And before I do any of the pins, I'm going to solder one of the support lugs so things are not going to back out on me. Go flopping around, and I'm going to double check to make sure all the pins went all the way through their holes. And I'll reheat this again, applying some firm pressure to the LCD to make sure it's fully flat on the board, and it is. Now I can get rid of that little piece of foam. Actually, I'm going to keep that on there just for 1 second here while I do the other support lug. Okay, now I'm looking at these solder pads, and the only thing, a couple of them, you may notice a couple of them are bridged together. Now these are all very, very close together, and that's making me nervous, because I obviously don't want the solder to bleed from one pad to the next. So let me give it a little try here to see what one pin, if I'm going to have to worry about that. I don't think so. The solder resist between the pads seems to be working. Now see right there, just did what I thought it might be doing and bridged all together. So what I'm going to do, because this will drive me somewhat frantic if I try and I think I separated those. I'm going to go into continuity mode on my meter. To see if those are bridged. And they are not. That would be bridged. Yep. Unless they're bridged through the thing. No, they're separate. But what I'm going to do, because I don't like what I'm seeing here, if that happened already for me, and as you know, I'm reasonably proficient at soldering, I'm going to take my Chip Quick flux paste and be a little paranoid and treat this as if it was a surface mount board, and I'm going to spread flux all along here globbing it on to make sure that the solder only goes where we want it to go and doesn't go to the bridging across. Little tub of flux like this, which you can get on Amazon or Mauser or wherever you want to buy your electronic parts, costs about, it's not cheap, it's like $20–$30 for this 2-ounce tub, but it'll last forever. I mean, this one, doing a good bit of surface mount, this one's lasted a year or more. Okay, now that I've got some flux on there, I think I can more confidently solder the rest of these pins and not bridge. Actually, I just bridged again. Man, this is, they mark this as a level 3, and I can see what they're talking about. This is not a beginner kit, because of how close together the leads, the pins are on this display. I'm going to get my head in the shot, folks. I'm sorry, I'll go to the side camera, because you gotta just be very, treat this like a surface mount project now. And with the flux and going very carefully, I'm doing okay. Okay, that was not all that successful. I bridged quite a few pins, so I'm going to have to go back and solder suck all the bridgings off. So we're back, and actually it's been a good bit of time. I had to go through and rework a lot of the pins here, and I think I got them all good. Now we're going to work on the base PCB, because the display and control PCB board is done, and we'll work on this. And now we're going to continue going down the list of items on the board, on the strip here, and we've got 1, 2, 3, 4, 5, 6, 7, 8 BAT 85s. 1, 2, 3, 4, 5, 6, 7, 8, and one Zener diode, one SV1. So we want to make sure we don't pull that Zener off right now and confuse ourselves. And of course, the printing on these diodes is pretty small, so just be careful and take a good look at them. Come on out of the tape there, little diode leads. Yep. So they're going to go in D1 through D8, and they've got a black line on them, which is where they will match with the white stripe on the circuit board. And as you can see, probably I bent the leads too close to the body. The leads are way spread out on the circuit board. Forgot to solder one here, but I'll get to that with the rest of the stuff, because now we'll put the Zener in. Now we'll get these little ceramic 104 capacitors, decoupling caps for the power going to the ICs, and that will be C11, 12, 13, 14, 15, 16. C11 through 14. I mean 16. I just said it. Now they want us to put the IC sockets on. Okay. Well, I know why. Even though we've got a bunch of resistors left, they want all these, they're all vertical, they're all stand-up resistors. So we'll do them after we get the lower parts down, and we match the notch on the socket with the notch printed on the board. And I'm going to try and get all these on in one attempt. Where's the other socket? There's the other socket. That's the sockets. What do we want to do next? We want to do a switch. Here's a switch. Angled legs. And it goes over here where it says SW1. And this one I'm going to be, oh, I guess that does lay pretty much flat. Okay, good. I thought I was going to have to really poke at it, but I won't need to. And now we have a coil. Actually, they mean an inductor. And should be brown, black, brown, yep. 100 microhenries, and where is it? There it is. It's L1. Now we're going to put the two trimmers on. We've got two of them. They're both 5K. We should have two of them. Oh, there it is. They're both 5K. So we don't have to worry about which one goes where. That's dandy. Now we're going to do some more ceramic caps, which let me trim this off for a second. Let me get all the other ceramic caps out. And now we'll go ahead and put all those on the board. Again, there's a variety of them. There's 101s, 105s, 47, 15, 10, 471, 2.2, 681, and 6.8. So there's a lot to look at here. Make sure you get them all right. And when they're in tape like this, don't try and pull it out of the tape. Just clip the tape. Just clip the leads. If you try and pull it out of this assembly tape, it will fight you and you might damage something. So there's a bunch of them all over the board. And that's all the ceramic capacitors down. Now I've got to change camera batteries, so I will be back in a bit for flash. Now it's extended resistor time for this board. And the resistors are in, as I mentioned earlier, they are in the order of assembly, but it's good to check. 666. Yeah, they look like they're in the right order, but I will be double checking along the way. And again, they are all stand-up resistors, which I've already expressed my dislike for that. But we'll put them on with no further commentary than that, because they're basically going on the same as they did on the display board. So I'll be speeding up the cameras and, as before, probably cutting a bunch of it out. Now we've got a PCB tab, which is this little metal thing. It goes in SK8. Here's SK7, here's SK4, SK1, SK2, 5, 6. Come on, finding everything but 8. There it is. It's a test point. Get a little piece of foam to support that while I solder it. Now we're going to do the transistors. There are 3 337s, 1 327, and they've got an exclamation point near it. So you're aware, that's the 27, I believe. Let me look at the, oh yeah, well it has to be, because these are the 3 337s. So again, we'll clip them out of the manufacturing tape. And T1, let's see how they're spread. They are spread with the middle lead back. And we'll put the voltage regulator on also. That's those. Now we'll take the relay and we'll look at it, and it's got a very specific pin pattern. So it should not be difficult to get in correctly. Looks like they might have 2 of them. One's got a bigger footprint, but this one goes in the box that's right there. Now the electrolytic caps. Now that's all the components. Now we're going to go ahead and finish the connectivity side of things. I think this goes this way. I wonder if it's got this is unclear. Oh no, that's the way it goes. I'm looking at it. Just if you're going to put this on, look at the diagram, and you'll see it's facing this way with the short side of the circuit board right there, and the long side that way. So that means it's got to go that way. So that's good to know. Now we will put the ICs in here, and we've got, again, we've got the ones we've already talked about. And main thing here, of course, is just to make sure the notch is going the correct way. In this case, this has a dot instead of a notch. All the pins are in, nothing's bent on that one. This one has an actual notch. All the pins in, nothing bent. Now we'll put the microcontroller in it. PIC. And as we pointed out before, it's got a little mark on it showing that it has been programmed. Bend those in a little bit more. All in, none bent. Good. Now we'll do the test leads, which we've got over here in this bag, which I gotta cut open. And they say tin the test leads, but they are already tinned. So question is, where do they go? Don't go there.
Oh, here we are. I think. Yeah, because it's pointing out where the where the relay is. So we're gonna, they want us to thread it like this through this hole, pull it out, and go back up through the hole next to it. I'm assuming that's to give it a little strain relief, so if you tug on the probes, you're not going to have a problem. Now I'm going to snug these wires back up so they're not so much flopping in the air. And now we'll hook up the battery box, and we don't have wire for it, so we'll have to make our own wire. I'm going to bend these tabs up a little bit. We've got, should have 2 pieces of wire. Why do I only have 1 piece of wire? Where'd my piece of black wire go? I don't know. Fortunately, I got a lot of black wire. Back in a second or two. Strip these, tin them, and the red one goes to this positive terminal here. You can look and you can see the positive sign inside the battery box. Now we do the same thing over here. Okay dokie. Place the base PCB on top of the back side of the cardboard cover and trace the opening on the cardboard. What? What cardboard? Do they mean this? Oh, they must mean this. Oh, I see what they're saying. They just want you to, they want you to know where to put the hook and loop fastener. So, where's a pencil? That's where we'll put the hook and loop fastener. Here we've got it, and we're going to trim it off a little bit. I think this is going to hold the battery box in place. But it doesn't actually say that. I'm going to turn this off because they want us to put the batteries in. Let me go get 4 AA's. I mean AAA's. I'm going to recycle the cameras because I'm down to 6 minutes. There, we're back. I don't know if I'm going to put the hook and loop on the battery box or not. We'll see. I'm going to make sure the switch is off, and I'm going to put all the batteries in. It's nice that this may be able to run off just these 6 volts of power. Now I'm just going to go in there somewhat like that. I guess I'll put the hook and loop on right there. I mean the hook side right there. Shouldn't have taken the backing. Shouldn't have taken the backing off. But that's just because I'm silly. Put that there, kind of roughly. So that goes through there, and now we take, we're going to go from the, first we're going to mate the 2 boards, like so. Squinch. Leaves a lot of gap, but that's okay. Now we have some screws and a bunch of spacers, and at the first part you need 2 spacers. Like so. Push that through. Then we'll get another spacer. And we'll put this where it's supposed to be on, no, it does want to go that way. I'm sorry, I confused myself again. And now we'll put the backing on this, and again I'm not doing it all the way tight right now. I'm just going to thread the nut a little bit on so it doesn't all fall apart on me. Now we can kind of get the, oops, well that's, I did that backwards. Okay, it doesn't much matter. It does matter. Ah well. I messed up, folks. I wasn't paying attention and I put this on wrong. So we really want this kind of over here. And it'll stick well enough for gummit work, as I used to say when I was in the Air Force. Maximum input voltage for this thing is 30 volts. It's not a lot. And then we've got holes so we can get at those 2 trimmers that we put on to calibrate the thing, which we'll be doing in a little bit. But let me put the rest of these screws and spacers on. Okay, so that is it assembled. Here's the front, the side, the back, the other side, the top, and the bottom. Now I'm going to turn it on, see if anything actually works. Velleman Educational 30p input, press menu to accept. Well, that's nice, it seems to be working. Got nothing going on yet, but we need to calibrate this right now. So we're going to calibrate it with a 1.5 volt battery. So let me get one of those. I'm back with the battery, but I also did a couple other things. I cleaned up the workbench a little bit, got some junk out of my way. I also grabbed out my function generator so we can send signals into this. So what do we want to do first? We want to calibrate it. We want to check things. Okay, max 30 volts input. Press menu to accept. And I'm going to go into the menu and look at some other stuff, because this says use down arrow to go to measure. And set that to VDC, volts DC, good. What else do we have in here? Markers, time mark, run, contrast. Oh, that's good. Let me see, because you can probably barely see this. I can barely see it. Let me turn the contrast up. Oops, pressing the wrong button. Oh, let me see how high, oh, 7 is the highest it goes. That looks good to me, though. Now, as we can see here, we've got a flat line at 0 volts, even though it's not actually at 0 volts. Let me see if I can adjust that to start. I'm turning the gain knob. There we go, that's dead on at 0 volts. Now I'll put this battery on it that's fresh off the charger, and there it is. Okay, it's right at, let me see if I can hold the battery leads and then do this so that, God darn it. So we've got the 0 line here, that's half, that's 1, that's 1.5. So by calibrating it to 0, I also calibrated it to 1.5, so that's just perfect.
Now let's send some signals into this little fella, because it seems to be working just fine. That holds the current signal, and you can see there's a little outline that goes around it. But let me connect I should have a sine wave up here. Yeah, I have a sine wave up, showing nothing yet because I've only got one side going. Now I'll connect the ground, if I can do it. These alligator clips. Oh, there you go. That's a nice little sine wave. Let me change the wave. There's a square. Yep, that's a square. Then we got a CMOS square, a trigger signal. Adjustable pulse width. Let me see if I can adjust that. Let me change the frequency. Yeah. It's tracking pretty well. I don't know whether the raggedy stuff is my... Actually, let me bring up my other scope, my main scope. Because I want to see whether this raggediness is from my signal or from this device. Come on, boot up, you Siglent thing. Siglent takes so long to boot up sometimes. So you can't see the scope, and I'm not moving the camera around so you can see it, because that'd eat up a bunch of time. Well, I'm not seeing that raggediness in the scope picture on my Siglent, so it must be this device is a little flaky, just a little bit, not enough to really worry about it. I'm trying to clip it back on again. And there we go, we got that one. Let's do another waveform. Oh, do you see how it auto-ranged there? That was pretty neat. Let me change the amplitude and see how it auto-ranges down. Because yeah, see? The volts per div is changing automatically there. It just went to 1 volt per div. And if I go down, it's at half a volt per div. So it's doing auto-ranging really well. Change the waveform again. Now that's a ramp. See, there's raggediness in the analysis on this device. I don't know what that's from. I'm not too worried about it. It's minor. Auto trigger. Let me see if I've got, let me do AC coupling. And there we go. Now it's going through the center line again. Oh no, this is working just fine. This is a handy, and again, you can see it's backlit too, so you can carry it around and do whatever. And because it only takes 4 batteries, that's not bad. Oh, and we can change volts per div here too on the horizontal axis. So that's handy. And change it on the vertical axis too with the up and down. And run and stop. So that's it. As you saw, it's a pretty straightforward build, except for this edge connector. I mean, this connector for the LCD display, that was a pain. I mean, as you can see from my channel, I'm a pretty experienced assembler and solderer, and I had to go back and rework stuff. So if you have a youngster who's going to do this, that's an area you're both going to want to really focus, concentrate on, and take your time on. But you can certainly get it done. But other than that, it's a good little unit. You carry it around the shop. Very handy. Another nice one from Whadda Velleman. And I hope you enjoyed the video.